Have you ever wondered what happens to this bottle of water after you are done with it and discard it in the recycling bin? This bottle of water is made of a plastic called PET, polyethylene terephthalate, has a 92% chance to end up in a landfill. Plastic waste is resulting in an ecological disaster displayed by microplastic particles polluting our waters, streams, oceans, soils, and our food. Microplastics are created by the weathering and breakdown of plastic objects. Plastic waste management is a global challenge that needs to be addressed, and plastics should be integrated into a circular economy. Circular economy is a model of production and consumption which involves sharing, leasing, reusing, repairing, refurbishing, and recycling existing materials and products as long as possible. Circular economy is the ability of continuously reinserting waste in our economy, not one time, but in a permanent way. Now to the important research question. Can a bottle of water be recycled into another bottle of water? Currently, it can be done. To better understand the problem, we should understand how a bottle of water is manufactured. Water bottles are formed with a process called blow molding. The process starts with virgin plastic in the form of pellets. The pellets are melted using an injection molding machine and injected into a mold to create preforms. The preform is stretched into a mold using heat and pressure. The stretching ability of the plastic is essential for the success of the process. In contrast with metals that are formed of atoms, plastics are composed of very large molecular chains that can slip along each other at high temperature and form bonds at room temperature. Plastic loses their stretching ability with recycling. To better understand the challenge with recycling, we need to understand also how mechanical recycling is performed when attempting recycling water bottle. The bottles are shredded, then washed from any residual. The shredding process itself alterates the material by making the molecular chain shorter. To help you visualize the problem, let's assume the following. The long molecular chain of plastic can be assimilated to a bunch of linguine pasta. When using a fork, you will always be grabbing a bunch of the linguine that are entangled with each other. When those linguine are shredded into small pieces, it becomes very hard to grab a bunch simultaneously. When recycled, the molecular chain becomes shorter and shorter. It becomes impossible to use the plastic to make another plastic bottle. At the College of Engineering and Computer Science at the University of Michigan-Dearborn, a group of faculty and students is joining the global effort in finding innovative solutions for recycling plastics and integrating them in a circular economical process. For such a complex problem, a multidisciplinary team of researchers is needed. Students and faculty are working together to solve this problem here at UM-Dearborn. The big idea we are currently implementing and testing is to heal the molecular chain back to their original length and use plastic in 3D printing. Sustainability Student Organization will be working with faculty on an awareness campaign to collect waste plastics on campus and recycle it into indoor and outdoor furniture that they design. Although it seems simple, it is one of the most challenging problems of our time. At the CECS, we are equipped with a state-of-the-art laboratory to rise to the challenge.